Welcome in new video. In this video we're going to build very simple REST API with Spring Boot. We're going to use Spring Web, and also we're going to use Testcontainers to test our API calls. Basically, we're going to use Testcontainers to spin up MySQL, and we're going to run tests with totally separated MySQL instance for those tests. Okay, let's do it. So here, let's create a project. Let's call it customer REST API. My company. Yeah, we're going to change the group. We're going to keep Java 17. The language is going to be Java, and we're going to use Maven. And next step, we're choosing Spring Boot 3.1.0. We need to add some dependencies. We're going to use Spring Web JPA to interact with the database. The String JPA offers us Hibernate, so Hibernate is gonna talk to database via repository, and we're going to be able to retrieve data from database or save data into database and all sort of interaction related to database. We also going to add Lombok, MySQL driver, and also Testcontainers. Yeah, that's all the dependencies that we need. Spring Web allow us to build a REST API. Like I said, Spring Data JPA allow us to interact with database. Lombok is gonna add some add some annotation via Lombok, and we don't need to create like manually write code for for example, for getters, setters, or constructors. MySQL driver required for database communication, and because we're going to use MySQL database for that, and Testcontainers, of course, to spin up Docker containers. And yeah, let's finish. So the project is ready. We're pulling all the dependencies. We should get all the dependencies here. If we scroll down, we can see we have Testcontainers here. That's what we need. Yeah, that's great. So yeah, so let's have a look into the structure of our application. Java, and here we have a tests, and we're going to use Docker for that. Here is my Docker desktop. I don't have any containers, any images or volumes. It's totally fresh. So let's create a Docker and Compose file. New file, Docker Compose, and let's use Docker Compose to spin up our database. I said we're going to use Testcontainers, but Testcontainers is going to be used just for tests, not to actually to spin up database used via our API, REST API. So what I'm doing here, I'm creating that Docker Compose file. I'm choosing the version 3.3, and I'm creating services. We're going to use just one service. I named the service DB. Is using image MySQL on the latest. We can skip the latest tag, but I like to add it. Restart always. We're gonna restart. We're gonna add MySQL required environment variables. So the name is MySQL root password, and we're going to set it as password. And also MySQL database, and we give a name to the database. It's going to be testdb. No worries. Ports, we're going to map some ports, 3306 to 3306. So 3306 is default port for MySQL. We're going to map to the same port on our local machine. And volumes is going to be used to persist the data from our database into local machine. So whenever we Whenever we turn off our container, or we restart it, or we do something funny with it, we're going to have still our data in the database. The data, otherwise the data will just vanish, it will be gone. But if we add volumes, those volumes going to persist data from the container on my local machine. Sorry if I make any typos, I'll explain you what I'm doing here. I just need to type everything. So driver is going to be to local. All right, so like I said, I mapped the ports 3306 to 3306, and I have just those volumes, one volume. I'm naming it that volume mydb. You don't need to specify path. You can in a Docker, you can specify exact path when you want to store that kind of those files, but Docker is smart enough just to organize that stuff for himself. We just name the volume like that, and we specify after that colon, we specify what we want to map. So that's the path managed by Docker on my local machine, and that's the path in the container. In that on that path, sorry, this is MySQL actually. MySQL. So that was typo. Yeah, we're expecting typos. No worries. So on that path, the MySQL is storing the files. It means our database. So here I also have to mention that I'm using that that volume. So I need to just pass it. What kind of driver is it? It's local. So yeah, it should be fine. Now, so like I showed you before, the Docker is empty. I will try to spin that Docker compose. So let's go to terminal and write Docker compose app -d. Hyphen is mean detached. The terminal is gonna be detached, so I won't be able to see the logs. Docker is pulling the image. Image is gonna be visible here whenever the pulling is finished. So I will be able to see image here and here. Yeah, image is here, and here I can see the container. The container is spinning. It should be fine. Port 306. MySQL is process done, ready for startup. Great. So Docker is spinning, and we can keep it running. But now we can build our API. So I'll create new package, name it domain customer, and in that domain I have to create file. Let's just jump into whiteboard. I have prepared whiteboard over here, and what we want to do, what files do we need, because as a user, when you user or client, let's say client can be like a person. Yeah, that's the client. That can be you, or it can be another like computer. Yeah, another computer can be client, or mobile phone. So let's say this is like iPhone can be client. Those are our clients. Yeah, clients of our API clients. So as a client usually never access database straight away. So if that's the database here, client shouldn't access database straight away, because otherwise it needs to like understand SQL language, and after map that language to something, and so is another way. Like, we not interacting with database straight away. There's like few layers in like modern apps. So I will write it down here. So that beautiful thing here, like that beautiful thing. Yeah, I can imagine how beautiful that thing is. So it has the DB. Wow, sorry, but there's something wrong with the mouse. It's jumping like mad. So this is not PB, this is DB. So yeah, this is like DB, it's not PB. It's beautiful DB anyway. So here is our client. Let's draw like a person. So this is a client, and client make calls, HTTP calls to, let's say, something in our app. So this is HTTP request. Actually, for example, like get request. He wants list of our customers. So he interacts with controller. Controller is gonna pick up that request and recognize that, oh, that's the HTTP request. And let me use like text here. It's gonna be easier. So let's assume like we have HTTP, and we have local host, and our app is spinning on port 8080, and here we have endpoint customers. So that client wants to get list of all customers. So he specified that request, that URL, sorry, HTTP. He specified that URL in his browser or Postman, and he doesn't interact with database like straight away, like it doesn't go here. Oops, sorry, but that mouse is just mad. So it doesn't go straight away here. We got those layers. So first, he like interact with controller. Controller recognize what kind of request is that, and he maps that request to methods that he have. We're gonna specify those mapping in controller, and controller also doesn't speak with. He can, oops, he can, but it's not like that. So controller doesn't speak with database also. So no, that's not happening. We have another layer here. We need to think about business layer, and that business layer can be like service. So service, the service, a lot of logic can be. Control is just like mapping requests and send and call specific methods in the service, and service like do all this business logic that we want. We want from that request, like pull me that one, pull me that one, save the customer, pull the list of the customer, all that stuff. And that the logic can be advanced. Yeah, the service can do a lot of things, can call another services, do something with the data, and then persist it. And service doesn't speak with database also. Yeah, that's not like that. It doesn't speak. We usually have another layer. That's the repository. That's the repository. I call it repo because writing with mouse is not really perfect. And service speak to repository, request something from repository, and repository is like not directly, but he's the guy who speaks with database. And here in Spring we had that hibernate, hibernate. So ORM, object relational mapping. So it's mapping like objects to relations in a database. That the guy is here like is like a middle guy hidden. We don't need to know much about hibernate. It's like semi-automated thing happening here. So yeah, we're going to have like those three layers: controller, service, and repository. And the repository is gonna talk with the database through hibernate. Yeah, so in that service, to remember, we can implement logic in the service methods. We can maybe have like special service like that can, for example, like checking the user if the user is valid or authenticated, or some other stuff, or maybe transform the user to something else, like different like DTOs, and pulling those DTOs and getting them back, and a lot of things can happen in here. But we're gonna keep it simple, nothing like fancy. So yeah, so let's create those layers. So first things that we need customer. Customer is gonna be our entity. Entity is like a one-to-one mapping with the table in your database. So we're gonna add here annotation entity. That's the entity coming from Jakarta persistence in that version of a Spring Boot. So we have customer entity, and it's starting to complain, oh, I need an ID attribute, because it's entity. Every table should have like primary ID, primary key or ID. So here we need to specify what is actually the key or ID for our table. So sorry, so this is going to be private UUI ID, customer ID, and here we can specify that this is ID, and another is a generated value. What is your UI ID? Usually people are using values like long. That's very popular. You can see long because long is a very long number, and you don't expect to have more records than the length of that long. Yeah, but it's not like that. Using like the numbers can cause a lot of problems, especially if you make like migrations. For example, you want to migrate two tables of customers, one from one app and another from another app. For example, you decide to build two applications, or you bought another company, and another company has also a list of customers, and those customers have ID. So imagine if you have like in one company have ID 1, that's for example John Doe, and his age is like 29, for example. Another is Mike Smith, and his age is 40, and so on. Yeah, the numbers go. So that's the one scenario, like company 1 or table 1, and you but you want to merge another table to it, which name is like customers again, so from another company. And for example, it's starting also from 1, but has of course different customers here, like my Flores, Annika, Paul. Yeah, so can you see the issue? If you want to merge those two tables, the customers are totally different. Yeah, totally different entities, the people, but the IDs are repeated, so that's going to be conflict. So we want to avoid that. So using UUID solve that problem at the moment. UUID is like 33.6 characters with hyphens, because it's actually 32 characters plus 4 hyphens. So this is like long string hexadecimal. So I'm going to show you how it looks like soon. So don't worry about that. But UUID is not just unique for your application, it's globally unique, because it's 128 bits long. It can generate so many combination that is actually impossible to name that number. It's so big. It's actually 39 digit in that number, 39 long digit, that many combinations. So if everything is wrong with hashing methods and all that stuff, there's no way to repeat that the same UUID globally. So it's a really fantastic thing at the moment, and hopefully it's gonna stay with us for longer, and we're not gonna have any conflicts with those UUIDs. Okay, that's enough about UUIDs. Let's add another field for that person, and that's gonna be like first name, and another string last name. We're gonna keep it simple, or we can add of course age, like int age, for example. Yeah, why not? And traditionally we can create like getters and setters and all that stuff, like I said before, but we want to use Lombok. So Lombok allows us to do that. We can give annotation data, because it's entity. We can give all args constructor, no args constructor to it, and yeah, we can specify of course our own constructor. So constructor and do like that if we have to, so no worries about that. And we can also add getter and setter. That might be required for JPA, so let's add those. Okay, entity is solved, it should be fine. And we can try to spin the application, but the application will fail. Why is it going to fail? Because even though we have the MySQL running in our Docker, yeah, we have that MySQL container running, we didn't specify to Spring how to actually connect with the database, and he's got that MySQL driver here. There's Testcontainers drivers, where is it? MySQL connector J, yeah, so that has connector, and has also Spring Data JPA, but it doesn't know how to talk. He doesn't know what's the name of database, what's the user, what's the password. So that's why we're getting that nasty error here, but that's not the problem. We have to go to resources in a main directory and application properties, and we can copy and paste, yeah, because it's quite a few things. Standard properties for connecting to the database, like here is a URL to connect with the database, so localhost and port 3306, because we map that port here. So yeah, that's the port, so no worries. And testdb is also, I don't think, yeah, we have that name here, testdb. We can change it to, for example, customers, like that, but we need to change that name also here. So customers, That's the username is root. You remember also here we specify root password. We don't need to specify a root user because MySQL got the root user by default. We need to specify here password and database. So the password is password and is using user root. And here's Hibernate DDL auto. So what it does, we have a little hint here. If we check update the schema if necessary, because Hibernate is very smart, because we've created that entity here. We give annotation entity. So Hibernate will check that, and he will see like, oh, you have the entity name customer, and if we can even specify here like a name customers, something like that. Yeah, we can give a name for that entity, but by default the name is customer. So Hibernate will create customer table with those fields for us automatically. We don't need to specify any SQL code, any query to create those table. Maybe if you know SQL, you know like to create table you need to use query like create table, and you specify like what fields you need and all that stuff. Table like customer and you specify what fields you need, yeah, here, and keys and all that stuff. No, Hibernate will do that for us. So that's the magic of Hibernate. It's a very useful thing. So here update will create an update schema if that's necessary. If you add another field here, for example like email or something like that, Hibernate would see that difference, and he will update the schema for us. And here another thing is like driver. That's the because it's 11 June 2023, so that's the latest driver for MySQL. So he will know how to speak with MySQL database. So yeah, let's try if it's working. It should be fine, hopefully. Yeah, it's fine. Oh, it's not. So what's happening here? Error creating being with manager entity. Something went wrong. Unknown database customers. Okay, no, okay, yeah, that's good. Actually, it's good that thing happened. Because here I had like different testdb before, and I just changed the name, and I didn't like spin the new container with those changes. So let's go to terminal, and we use Docker Compose app before to start the container. So now we're using Docker Compose down to put everything down, so everything will disappear. So we don't have the container. We still have image though, because the image is not container, is like universal thing, and we can for now we can just delete the volumes. So again, let's spin up the container, Docker Compose app -d, and it doesn't need to pull the image because he's got the image. So the container is spinning now, is very fast, stopping server, the down MySQL, everything is all right. So now if I run the app, it should be all right. Yeah, it's fine. So the app is working. It's got connection with MySQL. So we're not getting any errors, so everything is fine. So we can go back to that beautiful drawing here, and we can create controller service and repository files now. So let's do that now. So new Java class, customer service, another file, customer repository, but that's not gonna be class, that's gonna be interface. Yeah, so that's gonna be interface. We're gonna change that a little bit later. And another file, customer controller. So we got all those guys. We have entity, we have service layer, we have entity, we have controller layer. So that control layer that is like indirectly accessed by client. With all those mappings, we have service layer and we have repository layer. That's all the layers that we need. And we have that entity here, customer, that we're going to use. That's our customer. So in that customer repository interface, we need to extend JPA repository. And as you saw here, it's had that interface, JPA interface, got two generics, T and ID. So as T, we have to put our entity, and ID is going to be type used for the ID field. And as you probably remember, our entity name is customer, and the ID field type is UUID, is the type that we used here. If we use long, if you use string or whatever, you have to use the same type here. So repository is fine. It's probably we don't need to touch it anymore. So we can close the file. Customer service. Customer service, we need to add annotation service. We can add different annotation like component, but service is like meaningful name, so we know it's a service. And a customer controller, we can go here and add annotation REST controller, because we build in REST API. We also have MVC controller. If we pull actually for MVC now is like controller, so that's for MVC kind of apps that have also like templates and HTML files. So but we're not going to use that. We're going to just build REST API, and here we can add request mapping. So how we want the URL looks like. So when I told you before, like our URL is going to look like that: HTTP localhost port 8080, and here we're going to use customers, yeah, or customer, let's say customer, and that part is like known for Spring. That thing doesn't change. But our request mapping is actually that part here. Whatever is happening after that, if you want to call it like cat or puppy, we can call it puppy, no problem. Yeah, we can have it puppy, but puppy is not like meaningful name, so we want to stick with customer, and yeah, that's the request mapping. That's why we need that thing. And also maybe we can add some logging, SLF4J. You don't need to put any dependencies. That dependency should be already available there. SLF4J will allow us to create nice looking logs. We don't need to use like system out print line. Just we're going to use logs to log something to our terminal here. So here we're going to see the logs, and yeah, so control is ready, service is ready, and yeah, we can start with mapping. So I'll show you how the mapping looks like. So we're going to create method public string do something and return hi there. So that's example. It's not like related to our app, but I want to show you how the endpoints work. So that's going to be get mapping. So what I want to do, if I go to customer.url and I press enter in the browser or on Postman, I want to see text hi there, because I specify that thing is returning string, and that's the string. So here I have Postman, and let's add some requests here. Get dummy text, and request type is get, and path HTTP localhost 8080 standard post that we're using in our app is somewhere there. Is here, like Tomcat started on port 8080. If you're using different port, of course you need to change that port. And our request mapping was customer. Yeah, that was that. Customer or customers. Maybe that was a typo there. So let me just spin application. Sorry, we need to restart Spring. Yeah, so I didn't stop it. So you need to stop and restart your app. So it will apply that code. Customer. Yeah. So I send the request and we have hi there. If we change this to post mapping, if I press send now, sorry, I'm forgetting about that. I should install DevTools to restart the app automatically, but I don't have it. So if I press send, doesn't work, but if I change the request to post, I should see the text. Yeah, so that's the story about a request. But first we're going to play with get mapping, and we want to do something useful. So get our customers, and we need to return something. So what we going to return? We're going to return list of customers, and here we're going to return null at this moment because we just want to test that endpoint. Oh, here is we can do something useful. We can add log info get all customers. Restart, of course, again restart. Post doesn't work. Let's use get customer 200. Okay, and here we have our log get all customers. If I press it again, I'll see another one, get all customers. So the logs are working. What we want to do here, like I said before, on our beautiful drawing, we want to controller to speak with the service and service with repo. So we need to, in that controller, we need to actually here we need to add that service private final customer service, because it's final. We need to inject it in the constructor like that. I hope you know what's going on here. So we can do in Spring, we can do auto wired bin, because customer service have annotation service, so it's already the bin in that Spring context in Spring container, so we can access it. And here we can auto wire it, or the better solution is to inject it via constructor like that, because it's easier to test later on. Yeah, that's the better solution than auto wiring. So the service is available in our controller. So here we can return customer service get all customers. Our service doesn't have that method yet, so we need to create it. So option enter, create method. It will take me to the service, and it will create that declaration of that method for me. So I have list of customers, get all customers in here. What I have to do, I have to speak with service speaks with repository. So here the same story, private final customer repository, inject in the constructor, and I have access to it. So return customer repository find all. Because we're using Hibernate and JPA, they offering us some basic methods that we can call on our database, like find all sorted, save something to database, save and flush, what's count, check if it exists, find by ID, find one, and so on. So here I can retrieve all the records from the table customers. So I can use method given by JPA and Hibernate for me. So find all, boom, ready, and it should work now. So I can restart the app, check my just to confirm if the mappings are all right. So I can go to that request and I change the name to get all customers. Let's save it, why not? And if I click send, I should get something. So status is okay, so the call was all right, and I'm getting empty list because there's nothing in my database yet. So it's returning list. It means it wants something, but it's returning empty. So it's actually correct. So here, get our customers, the log is ready. So if we have like retrieving customers, so why not to add a customer? So let's add a customer. So to add customer, we actually going to return the newly created customers. So we're gonna call it like save customer. Save customer. And here we're going to check mapping to post, because get is just to get something from URL via URL. So we're getting something, but to send something, we can use like post or put or patch. So post is used to like save new records. And here we're gonna retrieve the newly created customers, but we also have to pass here as a parameter like request body. So our request is gonna contain body, and is what is going to contain. It's going to contain customer. So I'm gonna pass it customer to Postman, and we're gonna send it to our app, and the app should save it. So save new customer, and here in SLF, because we're using that SLF4J, we can, in those logs, we can use that kind of structure. Here we can open and close curly brackets, and after comma here we can specify what should be injected there, and I want to inject that customer to string here. That's what it's going to do for us. So here what we're going to return from service, because that method is not accurate for that type, because that one is returning list and that one is actually returning one customer. So here I want to call create method save, and I will pass customer to it. The method doesn't exist, so I'll create the method automatically. So customer save customer, yada yada yada. So everything's working fine, and I can speak to my repository, save me the client. The method save is there, as you see, very simple. So it's working fine. So it should be fine now. Let me restart the Spring, and we're going to jump into Postman. We can duplicate that request, duplicate, and we're gonna change the name to save customer. We change the mapping to post. The endpoint is the same. If I click send, it should throw me an error, bad request. Resolve the request body is missing. So like I said before, we have that annotation here. Where is it? In controller here, like that request should contain like body, and something should be in the body. So here in the Postman, I'm selecting body, row, text. We're gonna send JSON, and what we send in there, we're gonna send our entity. We're going to send UUI ID not, because this is generated field, so we don't need to specify that one, but we need to send these two guys, first name and last name, as a JSON. So first name is gonna be Adam, and last name is gonna be Smith, Mr. Adam Smith, economy. So let's press send. It should be fine. Oh, we didn't pass age. Yeah, we also have age, so age is 0. So yeah, I forgot about age. So yeah, age is going to be like, let's say like 65. Why not? It actually should override that. Actually, no, it's creating few guys for me. So yeah. So let's see what's happening here. So we've created that Mr. Adam Smith few times, actually 1, 2, 3, 5 times. So it should appear 5 times in the database. And here, interesting thing, that's the UUI ID that I was talking about. So it's a string. You can see it's like very, very complicated string, and it will be very hard to get the same string again, globally probably, inshallah. So yeah, here we have that save method, and see if the get is gonna get something for us. Yep, the get is working. So all the Adam Smiths that I've made are existing in the database. So yeah, that thing is working. So let's think about another endpoint. Another endpoint, maybe to get one customer. We have to get all customers, but now we're gonna get just one. We're gonna retrieve just one guy from the database. So here we can change it to customers. Get one customer. And here we're going to pass string customer. We're gonna get customer by ID, but here we need to pass like let me just duplicate that one. I'll show you what I mean. So duplicate and get one. Get one. So here customers, I want to get one customer. Let's get that guy here. Adam Smith version 35 million. So I want that kind of request. Yeah, so I want to pass customer and the ID here, and it doesn't work because we don't have that. So let's create that kind of structure. I need to pass some arguments here. So that's going to be like path variable. So here I need to pass customer ID. I need to pass that ID here in my URL, And here I need to get annotation like path variable, and I don't need to do that because we have just one variable, but I can specify the name of it. So I have that get one customer. Let's change that one, get one customer, and it doesn't like it because this one is returning list. So we're gonna create new method in our service, get one customer by ID, like that. Why not? And customer ID, let's pass it here. The method doesn't exist, so let's create the method. Okay, now we can speak with the repository, customer repository, find by, oops, I lost it, find by ID. I can get the customer by ID, but it requires me to pass UUID, but I have string here. So what to do, UUID from string, I can transform it easily like that. But that one doesn't return me customer, and that one is returning me the optional. If I check here, like that, introduce variable, customer, customer optional. So we're getting customer optional, we're not getting customer. So what we can do something like that. For example, if customer optional is present, then return a customer optional get. If not, return null. So if we don't have a client, just return it null. We can simplify that one like that. So yeah, customer optional, return customer optional get, or else return null. So it should work now. Customer controller, we have it that here. So here we're going to get the customer. So let's restart Spring and see if that thing is working. So let's get one customer with ID. Let's do like that, and customer ID. So let's restart it again and check our endpoint if we can retrieve that gentleman from database. So yeah, we can get Mr. Adam. If we decide to pull that guy here, get one, it's fine. But if we change that one to like ID that doesn't exist, we not getting anything, but we're still getting status 200. Okay, so it would be nice to change that status to something different. To do that, we can return not customer, but we can return response entity, and we can specify here like that's going to be like our customer, let's call it customer. So that's going to return the customer, and here we can decide if customer is different than null. So it's not null. Return new response entity customer and HTTP status. Okay, but if something went wrong, return new response entity and just HTTP status not found. So not found, we're going to return not found. Let's restart Spring. So if we have customer, just return it and give a status all right. But if we didn't return customers, because this one returns null, the service can return null, give us not found. So okay, we don't have it, so not found. But if we go back here to ID that exists, it will get us 200. All right, so we have the simple API. I don't want to create more methods. That's enough to try test containers. Let's see what we have here. We have here like two default test method that we get for free, but we don't want to use that. We want to build our own. So let's create test method customer API test. Okay, name is not sophisticated, it's not like very important here. And here we also have to create, because we have that application properties that is used for API, but we need to do something like that for test as well. So here we clicking left right mouse button, new directory, we picking the resources, and in resources we need to create application properties, the same file. Let's copy the same things there, but they're going to be used for test. You can specify different here, like for test if you're using different ports, you can specify here, but we're gonna keep it like that, the same like here. Why? Because those values is gonna be overridden by test containers. I will show you in a minute how that thing works. So that should be fine. And let's now go back to our tests, and let's create a test with using with usage of test containers. So here, test containers, we give that annotation test containers. All right, and here we have to actually create the test container. So private static. Why static? Because that container is going to be available for all the test method within the class. If we not use the static, when we run test, there's going to be new container for each test, and it's really messy because, of course, it's nice isolation, but it will take a lot of resources to spin all those containers. Can you imagine if there is like 20 test methods? So you're going to get 20 containers. So it's quite resource consuming issue here. So static MySQL container, let's call it like MySQL container, why not? Equals new MySQL container, and here like in Docker Compose we have to pass what image we want to use. MySQL latest, so the tag is latest, why not? Sorry. So we have the container, we need to give it annotation, that's the container. So that's the container, and also like I said before, we need to override those values because our container is gonna work on a different port. It's gonna use different database name and password and all that stuff. We don't need to know what there are. This is not important in the test. Of course we can set those details in our container, no worries. We can specify that we need that password and exactly that user and that port, but for our case we don't need to do that because MySQL container will set everything for himself by himself. It's gonna work on the first random accessible port that he can find. He will draw like, oh, I want to work on that port, and actually MySQL is not gonna be accessible here on 3306. That port is going to be assigned by MySQL that container. Yeah, so we actually don't know what is it. We can get that information, and I'll show you how. So we need to create like public static void override props, like that, override properties, and here we need to pass one argument to that method, dynamic property registry. Well, let's call it registry, and here we need to add annotation like the dynamic property source. So that's the source of dynamic properties, and here we're gonna override those values. So registry add, and here we have to pass what we want to override. We want to override the URL. We want to override that. Let's close it. Let's close that. So we want to override that value. And here we're gonna get something in common. We want to override also username. Let's change it here. sorry for that. And we need to override that one as well. So we need to override those three properties, and here we're gonna take it from container. So MySQL container, and here we have access to something. We can get all those values from the container. So database name, password with username, and get username, get URL, and all that stuff. So here we're gonna get JDBC URL. So we're gonna override that URL from the URLs that we're getting from the container. And here we're going to get username, and if I use with username, I can specify what username I want to use. Yeah, I can say to container, oh, you have to use that username, not the different one, not the one that you want, but I want to just get it. In that case, I want to just get it from the container, so that's not the problem. And here get password. Yeah, so everything should be fine now. And here also I need to add one more annotation, and that's gonna be Spring Boot test and web environment. It's gonna be Spring Boot test, web environment, and none. Yeah, so I don't need like any environment for that, so that should be fine. We can now create tests, like let's see. So that code will spin for me a new instance of MySQL. I can stop that one now. I can stop that one, or I can delete it. Even if you don't believe me, I can delete that one, because we have so many John Smiths there, so it would be nice to delete. So if I run the test, it will spin up the container for me. Let's create test. Void when clean database, then should return 0. Yeah, so when the database clean, it should have like 0 customers in the table, right? So let's check that one. So customer service, oh yeah, I need to, because I want to use customer service, so I need to actually outwire that service. So private customer service, and I can outwire here, and it should be done. So customer service, get our customers, and here all customers. So we're gonna assert that all customers. Let's pull that assert from import assertions. Okay, assert hash size. Hash size. Probably I pull it from different package. So let's check again what's available here. Import from, yeah, assert jQuery API. Yeah, wrong package. Hash size 0. So hopefully, let's stop that Spring. We don't need to run Spring anymore, because tests gonna run in isolation. So let's run all the tests, and it's gonna take some time because you need to like pull the images. You see, it's got the images, and it will pull MySQL if it doesn't have, and it will create those images. So yeah, I have the image created by Testcontainers and standard Testcontainer image. The test is passing. Yeah, I have empty table in the customers. So yeah, now we can test, like if we add 1 customers, how many customers it will return when customer added should return 1. So let's do like that. Customer savers, save new customer. We're going to give him like name, like Michael Angelo, and age is gonna be 50, young, why not? Save. We're getting all the list of the customers, and we should get 1 should be saved. So run all the tests and check if they are passing. Let's check. Yeah, so I got my new containers here for those tests, and yeah, it takes 10 seconds to spin up the container. The test is passing, why not? Now we can think about tests to add more customers, but we have to do one thing. We have to delete everything from the table. Like I said, we have just one instance for entire class, right? Because we're using that static method with the test containers. So we supposed to have like one instance of MySQL for all the tests, and because we added already one customers, if I do something like that, when customers added, should return 2. When let's say 2 customers added, should return 2. Yeah, so let's duplicate that guy. Let's call that guy Alex, Al. Let's do like that. Yeah, it doesn't matter what we're gonna add here. We just are worried about the numbers of people, of customers. So let's try something like that and check what we're gonna get. I don't think we're gonna get good assertion here. I think it should return 3 because it will consider that guy and those 2 guys. So the number of all the customers in the table will be 3, not 2. Sorry. Yeah, expected size is 1, but it's 3. Yeah, so we've added the guy, and after assertions, and something is wrong there. So yeah, so we can think about in our customer service, we can add new method, public void, delete all, or we can work straight away on the repository, basically in the tests. We can also do something like that, but let's do it here, like customer repository, delete all. The method is ready already. Is ready there, served by JPA. So that's cool. And we can jump into tests and do like or before each like setup. We want to have like clean table setup, clean table. So we can try it now. I guess it will work fine. Yeah, everything is fine. So we're working on a clean table with each test. So yeah, what we can do with that assertion, we can assert also assert equals let's import that thingy from if for example Alex is customer service get all customers, get index. What should be the index of that guy? That index of the guy should be 0 and 1. Let's hopefully we are lucky. Oh, sorry, equals, something went wrong. Import static. Of course, get customer first name. Yeah, that's why there was an issue about types. Oh, something is wrong here. Wrong import. Let's try again. Yeah, it takes ages to start at test containers, but I think it's like good solution. Whenever the container is ready, it will be yeah, mistake, because the index of that will be index 0, that will be 1. So of index 0 is 1, and sorry and al will be the second record received from the table. Yeah, everything's fine, so tests are passing. So basically that is the basic use of test containers, and I show you also how to build like simple REST API. We can add different methods like update, patch, update and patch. They're like sort of similar requests types, but they're a little bit different as well. Like update requires you to send the entire object, and patch you can send just like parts of the object. You doesn't need to send entire object to update. Yeah, so that's the like subtle difference between patch and update. But patch is like very common one. I like use patch. So yeah, so that's the basic app. I hope you like it. Yeah.